final lesson in this module deals with the Poisson distribution. So far we've been talking about binomial distributions. Poisson is much different. With the Poisson distribution, you are looking at what you need in order to do this is you need the mean and you need the number that you're trying to get. You can have both PDF and CDF for Poisson distributions, just like for binomial. So you have to determine whether you're doing a PDF, which means you're looking at one, or whether you're doing a CDF, which means you're looking at a range of values. So we're going to look at this question that's dealing with the Poisson distribution. Just like with binomial, there are also things that you should check for Poisson. So refer back to your notes to look at that. In this case, again, I'm just telling you this is a Poisson distribution. What it says is you're looking at motor vehicle deaths. It says in Dutchess County, New York, they haven't experienced a mean of 35.4 motor vehicle deaths in each year. Okay, each year. Okay, that is the mean over the time period of a year. Now, one of the bad things about a Poisson distribution is the mean changes constantly based on a certain time interval. So you have to first make sure you look at that. Okay, part A asks us, find the mean number of deaths per day. So you have a different time interval. Well, I've got 35.4 per year. How many days are in a year? Well, there's 365. So if I take my mean per year and divide by my time interval, which like I said, this case is the number of days per year, I'm going to get 0.0970 if I round to 3 significant digits. That is my mean per day. Since you are going from a larger interval to a smaller interval, your mean should get smaller as well. I'm going from year to days. I actually have more days, but I'm going to a smaller one. Okay, in B, it says find the probability that on a given day there are more than 2 motor vehicle deaths. Okay, well, this goes back to figuring out whether you're doing PDF or CDF. Well, more than 2 is obviously looking for a range. Well, you don't have an upper limit for a Poisson distribution either, unlike what you do in binomial. With binomial, you have a mean upper limit, I should say. You have a sample size, and you're not going to exceed that sample size. For a Poisson distribution, it can go on to infinity. So obviously, you have to figure out how to do that. But more than 2 means 3, 4, 5, 6, on and on, forever, forever, and ever. Again, because you're doing more than, calculator only does less than. So we have to do 1 minus. All right, Poisson distribution is found in the same place where you find binomial. It's second bars, and you scroll down until you see Poisson. And we're looking for Poisson CDF because I'm doing a cumulative distribution function. All right, for a Poisson distribution, what you enter in parentheses is also different from binomial. For binomial, you need the mean, the probability of success, and the number you're looking for. For Poisson, all you need is the mean and the number you're looking for. So in this case, my mean per day was 0.0970. Okay, and I am looking for the number that's going to separate the upper group from the lower group. Remember, this is my upper group. So 3 starts my upper group. Go 1 less than that to stop your lower group. So I'm going to stop at 2. When you type this in the calculator, again, you get another scientific notation. So make sure you know how to read that. It's going to be 0, 0, 0, and then it's 1, 4, 1. So this is my probability of having more than 2 motor vehicle deaths on any given day. So part C says, is it unusual to have more than 2 motor vehicle deaths on the same day? You would say yes. This number is, again, obviously less than 0.05, which makes it unusual. So it is unusual to have more than 2 motor vehicle deaths on the same day. This is an example of a Poisson distribution.